we have AP calculus AB problem. Okay, let's go with the question. The region enclosed by the graph of y equals to sin x and the lines of y equals to 1 over 2, x equals to pi over 6 and x equals to 5 pi over 6 is rotated about the x-axis. What is the volume of the solid generated? Okay, now to get the volume of the solid generated, we have to sketch a graph for the given information. So here we have the curve y equals to sin x, and then we have the lines. So it's an horizontal line through the value 1 over 2 on the y-axis, and we have two vertical lines through the values pi over 6 and 5 pi over 6 on the x-axis. Okay, now let me sketch the graph for the given information. So it's x-axis, and so here we have y-axis, and let me mark it. So here we have y and x, and let me mark the value 1 over here, and here we have -1. Okay, now first let's sketch the graph of y equals to sin x. We know that the period of sin x is 2 pi. That is, we'll have one complete pattern of the graph of y equals to sin x from 0 to 2 pi. Now let's consider some random values from 0 to 2 pi for which the value of y in this function y equals to sin x. Let me consider x equals to 0. So when x equals to 0, the value of sin x is 0. That is, sin 0 is 0. That is, value of y is also 0. And let me consider the second value of x in this interval, that is pi over 2, that is 90 degrees in degree measure. So when x takes pi over 2, it becomes sin pi over 2. The value of sin pi over 2 is just 1, that is, the value of y is 1. And now let me consider x equals to pi. When x equals to pi, the value of sin pi is 0, that is, y equals to 0. And let me consider 270 degrees in radians is 3 pi over 2. So for when x equals to 3 pi over 2, the value of the trigonometric ratio sin is -1, that is, y equals to -1. And when x equals to 2 pi, the value of y equals to 0, that is, sin 2 pi is 0. Okay, now so clearly the graph of y equals to sin x is passing through the point origin 0, 0 over here. So let me mark it, and also let me mark some other values on the x-axis over here. So let me take 2 pi, and let me take pi over here. The exact middle portion of pi and 2 pi, we have 3 pi over 2. And here, so between 0 and pi, the exact middle value is pi over 2. Okay, so 0, 0 is the starting point we have for the graph. Let me make a point. And then we have pi over 2, 1, it's over here. And also pi, 0, it's over here. And 3 pi over 2, -1, it's over here. And 2 pi is over here. Okay, now let me sketch the graph. Here I have sketched the graph of y is equal to sin x through the marked points. Okay, now let me sketch the graph of the line y equals to 1 over 2. It's an horizontal line through the value 1 over 2 on y-axis, and so 1 over 2 is the exact middle value between 0 and 1 on the y-axis. So here it's 1 over 2. So this is the horizontal line y equals to 1 over 2. And now let me sketch, let me draw the lines, the vertical lines x equals to pi over 6 and x equals to 5 pi over 6. Let me draw it. So x equals to pi over 6 is just 30 degree. Let me draw it. Now let's sketch the line, vertical line x equals to 5 pi over 6. Actually, pi over 6 equals to 30 degrees. When 30 degrees is multiplied by 5, I'm getting 150 degrees. So this vertical line has to be close to pi, which is equal to 180 degrees. Okay, let me draw a vertical line over here. Okay, so this is a vertical line of 5 pi over 6. Okay, let me write the equation x equals to pi over 6 over here, and x equals to 5 pi over 6. And the two vertical lines I have drawn over here, x equals to pi over 6 and x equals to 5 pi over 6, and the horizontal line and also the graph of y equals sin x will be concurrent, because this vertical line and the horizontal line and the y equals sin x, all of them will intersect at a point over here, the same thing. So because when I plug in x equals to pi over 6 into this function y equal to sin x, I am getting y equals to sin pi over 6, that is, sin 30 degrees equals to 1/2. So this one and this one intersects, and also the horizontal line also will intersect the same point. And also when I plug in x equals to 5 pi over 6 into this function, I am getting y equals to 1 over 2. Okay, now let me shade the region enclosed by the curve, the horizontal line, the two vertical lines. So clearly this is a region enclosed by the curve y equals to sin x, the horizontal line and the two vertical lines. Now this region has to be rotated about the x-axis. When I do so, an hollow solid will be generated. So to have better understanding this one, let me draw a dotted line, dotted horizontal line at y is equal to -1 over 2. So this is the horizontal line of y is equal to -1 over 2. Okay, now when this region is rotated about x-axis, so there will be an hollow space in the middle over here. Okay, how do you have to get the hollow solid generated? So for that, what we have to do is, let's forget about the line y equals to 1 over 2. So just consider the entire region over here. That is the region from the curve y equals to sine x to the x-axis. Now, when this region is rotated about x-axis, so we'll be getting a volume including the hollow space in the middle. So once we get the volume, so we have to subtract the volume of the solid that we have in the hollow space over here in the middle. For that, we have to subtract the volume of the solid generated when this region is revolved about the x-axis. So now my idea is, let me consider the entire region over here between, the area covered by the curve y equals to sine x and the x-axis, the entire region has to be rotated about the x-axis, and let me get the volume. So once I get that volume, from that volume, I'll subtract the volume of the solid generated by this sine y equals to 1 over 2. This region is rotated about the x-axis. Okay, now let me write the required integral. So the required volume is equal to, usually whenever I want to get the volume of a solid which is rotated about the x-axis, the formula is pi y square dx. So here the limits for on the x-axis is pi over 6 to 5 pi over 6. Between these two vertical lines, we have the region. So the lower limit is pi over 6, upper limit is 5 pi over 6, pi y square dx. So for y, we have to consider the sine x, because now I'm going to get the volume of the solid that I'm getting when this complete region is rotated about x-axis. That is, this complete region is given by the curve y equals to sine x. This region is between the curve y equals to sine x and the x-axis. So y equals to y square means sine x whole square. Sine x whole square means it's sine square x dx. Now I'm getting the volume of the solid for the complete region. From this volume, I have to subtract the volume of the solid generated by this region covered by the horizontal line y is equal to 1 over 2 and x-axis when it is rotated. So here also the same formula, pi, and the limits of x are same, that is pi over 6 to 5 pi over 6. And here this time also we have to use the same formula, pi times integral y square dx. For this y, we have 1 over 2 the whole square dx. Okay, now we have pi times integral pi over 6 to 5 pi over 6. So how do you have to integrate sine square? So for that, we have to use the cosine double angle identity in trigonometry. So we know that sine square x equal to 1 negative cosine 2x divided by 2 dx negative, and here pi to pi times pi over 6 to 5 pi over 6. And so when I take square for 1 over 2, it will be 1/4 times dx. Here 2 is a constant, so we can move it out of the integral. So when this denominator 2 comes out of the integral, it will be 1 over 2. When this pi is multiplied by 1 over 2, it will be pi over 2 times integral pi over 6 to 5 pi over 6, 1 negative cosine 2x dx. And also we can move this constant 1 over 4 out of the integral. When it comes out, it will be multiplied by pi. Pi times 1 over 4 will be pi over 4 integral pi over 6 to 5 pi over 6 dx. Okay, now let me erase this stuff and continue the problem. This is the last step we had on the previous work. Okay, let me continue. Pi over 2. Okay, now let's integrate this stuff. Here we have the constant 1. When 1 is integrated with respect to x, we just get x. And negative, when we integrate cosine 2x with respect to x, it will be sine 2x, and it has to be divided by the coefficient of x over here, that is 2. And we have the limits of pi over 6 to 5 pi over 6 negative pi over 4 times so the integration of dx is just x, and we have the limits of pi over 6 to 5 pi over 6. Then we get pi over 2 times okay, now what I can do is I can plug in the upper limit for this complete result. Then I'm getting 5 pi over 6 negative sine 2 times 5 pi over 6 divided by 2. So now I have to take negative sign. In the same result, I have to plug in the lower limit, that is pi over 6 over here. Let me do it. Then I'm getting pi over 6 negative sine 2 times pi over 6. That is for this x. I plugged in the lower limit divided by 2 negative pi over 4 times. Okay, now in this result, we have to plug in the upper limit of 5 pi over 6 for x over here. Then I'm getting 5 pi over 6 take negative sign. In the same result, we have to plug in the lower limit, that is pi over 6. Okay, let me continue over here. So pi over 2 times 5 pi over 6 and negative sign. And here we can simplify this one. 2 goes into 2 1 times, 2 goes into 6 3 times. So then I'm getting sine 5 pi over 3 divided by 2. And also we can distribute the negative sign to this one and this one. Then I'm getting negative pi over 6 and negative times negative will become positive. And also we can simplify. 2 goes into 2 1 times, 2 goes into 6 3 times. I'm getting sine pi over 3 divided by 2 and negative pi over 4 times. So here two fractions are in subtraction with the same denominator 6. We can take the common denominator 6 and we can simplify the numerators 5 pi, negative pi. So it's just 4 pi, and also we can cancel this 4 and 4 over here, and pi over 2 times and we can combine this 5 pi over 6 and negative pi over 6. So both the fractions have the same denominator 6 and also they are in subtraction. So we can take the common denominator 6. 5 pi negative pi will be 4 pi over 6 negative, and so the value of sine 5 pi over 3 is what? Actually pi over 3 is 60 degrees. When I multiply the 60 degrees by 5, it's 300 degrees. So for my convenience, I just convert this radians to degrees. So pi over 3, 60 times 5, 300 degrees. 300 degrees is in fourth quadrant, and here we have 360 degrees, and so the reference angle is 60 degrees, or it's pi over 3 radians. Since the 300 degrees is in the fourth quadrant, actually the sign is negative in the fourth quadrant, and we can use a reference angle, that is pi over 3 radians over here, that is negative sine pi over 3 radians divided by 2, and we have simplified this one with 5 pi over 6. We don't have to write it again. So positive, and the value of sine pi over 3 is square root of 3 over 2 divided by 2, negative. So pi times pi is pi square divided by 6. Okay, let me continue over here. So pi over 2 times 4 pi over 6, it can be simplified. 2 goes into 4 2 times, 2 goes into 6 3 times. Then I'm getting 2 pi over 3, and also negative times negative will become positive. And the value of sine pi over 3 is square root of 3 over 2 divided by 2. Positive square root of 3 over 2 divided by 2, negative pi square over 6, pi over 2 times 2 pi over 3. Okay, here we are adding to same value. So for example, let's assume that x positive x equals to 2x. So here instead of x, we just have square root of 3 over 2 times 2. So positive 2x. Instead of x, we can write this stuff, that is 2 times square root of 3 over 2 divided by 2, negative pi square over 6. So here this 2 will cancel out. Then I'm getting pi over 2 times 2 pi over 3 positive square root of 3 over 2 negative pi square over 6. Okay, now let me erase all the stuff and continue the rest of the problem. This is the last step we have done the previous work. Okay, now let me distribute this pi over 2 to this one and this one. When you do such distribution, pi times 2 pi is 2 pi square divided by 2 times is 6. And also when I distribute this pi over 2 to this one, I have to multiply the numerators pi and square root of 3. Then I'm getting square root of 3 times pi divided by 2 times 2 is 4, negative pi square over 6. Here this one and this one are like terms because both the terms contain pi square, so we can combine them. So here to combine them, both of them are fractions and both of them have the same denominator 6, so we can take the common denominator 6 and we have to simplify the numerator, that is 2 pi square negative pi square. When I combine them, I'm just getting pi square positive square root of 3 over 4 times pi. Okay, now I got the volume of the solid generated, and we find this stuff exactly in answer choice C. The correct answer choice for this question is C.